Uh, Hello guys. How are you doing today? Um, as you could, I've not been able to forget what I want to say. So as you can see, I'm using a different system. Like my previous Linux system has like a Groovebox theme, and I mean it looks just like this, but it's just a different theme. Now I'm using a different one, and that's because um my system, like my mini PC, which I've been using to stream for a while now, basically as a problem with the SD card. Like my SSD got corrupted, so I have been trying to get a new SSD. So I lost all my data and my codes and some other important stuff that I have there. Uh, I mean, I was supposed to have a backup, but it was a new. Sorry, it is a new mini PC, so I didn't expect like the SD card to, you know, get get bad anytime soon. Uh, but I did figure out the problem, which was due to um, I'd say an update, because before the SD card got corrupted, I updated my system and I left it on while I go out. So I guess the new updates has like a specific program that keeps it like running, and then it takes up like my entire like RAM, and so my system overheat. Um, and my SD card got burnt or something. So yeah, so now I'm using my laptop to stream uh, because I don't want to give up just because my mini PC get destroyed. I want to stop streaming. And as you can see, also I'm now learning Go. This is because I finally understand Nix. I mean, I'm not expert, but I understand Nix to the extent that I could finally like create config and move around and stuff. Um, so I understand Nix to the extent that I could basically maintain my system, because that was mainly the main reason why I want to understand Nix, to maintain my system, to maybe do some development and stuff. But I think I'm okay. Uh, Now I have moved on to Go because I want to understand Go. I want to have a new language that I could use to build like my backend and some other stuff. So I want to. I'm just going to be streaming me doing this, and I'm not really doing tutorial. I don't really know anything about Go. I'm a newbie. I recently finished what is it? I think it was Go language. Yeah, I recently finished the tutorial, the Go tutorial. I recommend you to actually do this because it's very good. It's a good way to to understand how Go works and you know understand the basic of the Go language. And now I'm currently in a tour of Go, so um, it's more like an interactive introduction to Go, where you get to understand like the basic of the language, like the Go basic, syntax, data structure, and some other stuff. Uh, Really, I don't really know my way around learning this, but I figure out like going to the source to learn Go would be much more better for me than to watch it on YouTube. Uh, because watching it on YouTube might just give me the impression that I actually understand what I'm learning, but I'm not. So before I do that, I think I first of all need to like understand the language by myself. So yeah, so I did this already, and it's a very interesting documentation. And then I went on to creating a Go modules and then on and on and on and on. So Soon I'm going to probably move on to each of this, but for now I need to finish this before I move on to like all of this. So yeah, that's all I want to say, and let's start. So yeah, should I play like music? Okay. Yeah, one thing I find interesting in Go is um, I wouldn't say it's similar to Java, but like just a few things that kind of look similar in the sense that uh, in Java you'd have a bracket right there, right? And then you'd have your condition inside of the bracket and other kind of stuff. But in Go you don't have the bracket, and also you don't have a like a semicolon or something that says okay, like this line of code is this like line of code ends here, right? So that's quite interesting also. I think I've done this already. Oh, this is quite interesting. Like you can um, normally if you have a if statement, like you would not like this, right? You're just gonna do if v is less than name, return v, right? And it would check if v is less than name. But in this case, like you could have a statement like you can have like a show statement before the condition, which is pretty cool. I mean, if you want to do that without having to do that, you could just do like v is you could just say mat.pow, and you could just say like kilo to x, and we say n, and yeah, you would have something like this, right? And then you would not have like this one in here, and you just have to check like if v is less than um, lim, then you do this. I'm not sure if this would work, but let's see. So my import's not used. Well, I used mod in there. Did I miss something? Oh, sorry, I didn't use it. Mod dot like pal. Right, and then if I do this, yeah, like this is how I expect it to be. Like normally you would have like if v is less than name, then return v. But the cool thing is you can have that in here, so you don't need to do. So you don't need to like write it before. It's like if statement on steroid or something. V equals to mod dot pal. Oh, pal. Then we do hex n. But this is the first time I'm seeing like a semicolon because normally I thought like Go doesn't use like semicolon, but it's pretty cool. Okay, so if you try this now, it's the same thing. Interesting. Syntax error, expedit name v, expedit. Okay, interesting. Go. True. So I keep like a mini notes where I write down like what I learned about Go. So if with a short statement, if in Go, so it provides a way to write a short statement before the execution of a condition, so we can have like this. If you do code block, so we could have something like if v equals to mod dot pal, we could have like x and so in the code above you can see we have a statement in a if statement before the condition. This it can also be written like this. So we could also have like code block, just say go. We could have like we could have the statement first. I would have mod dot pal. What's going on? And then we'd have x, and we'd have n. So we could have the statement first, and then we would have the condition. Like this is like the actual way that I know that it's meant to be written, which works. But I mean that's just like another way to write it. Good. Okay. Try using v in the last return statement. Okay, if we use v in there, like if we don't return lame or return v, we get v's undefined. Yeah, obviously because v is within the if statement, right? If we want to draw it and make v like define, we'd have to define v outside of the if statement. I think this should work. So when we do return v, we get v. So yeah. So yeah. Variables declared inside an ifs short statement are also available inside of any of the ifs, any of the else book. Okay. So, so this basically means that if you declare a v in there, obviously it will be accessible by the if statement section, and normally it should be accessible by the else statement section, regardless. Like, yeah, got it. Oh, okay. I'm gonna be honest, I don't really know what this is saying. So I'm going to consult the only teacher I know at this point to help. Okay. Thank you. Today's Saturday, actually. So it doesn't evaluate this because the current time is like, I guess, uh, too far away. So the current time it's checking is not in 2 days, it's not in um, one day, it's not today. So it's always going to be like too far away because the time in the playground is quite different, which is understandable. So basically, Go does not run this, I guess. Once it finds a condition that it's been met, it just like warns that. Switch with no condition. Interesting. You could just say current time. Current time dot hours is less than 12. Then print. If the current time is less than 12, print good morning. And if the current time is less than 17, just like print good afternoon. Then forward. Then we have, let's write one more. Case current time dot hours. If the current time is greater than 17, then we would say fmt dot print ln. I want you to print, say good evening. The insurance. Interesting. And then we'll have a default, and then the default would be print let's say good night. Now that makes sense. So what I want to do now is let's get. So let me try this. Okay. Good evening. Yep, yep. The first statement refers to the execution of the function until the surrounding function returns. It's like when you like stop something like for a certain period of time because you're expecting like a return, right? This happens every day in real life. Right. So I assume in this case the hello will get printed before the word, which would give us hello world. So not unless the hello has been returned before the word would be. So if we defer both of them, are we gonna get word hello? Okay, so we get hello world regardless. So does it evaluate from the bottom to the top or from the top to the bottom? Let's try and add one more. I think that way we could know what happened. If we say like, okay, oh interesting. I guess it goes from the bottom to the top. Alright, so let's write about that. What can I use to like, what's the word to link this? It's like a payment before goods kind of thing. So weird. Like you need to pay before you get a service. The main idea of the for statement is um, it defers, say stops or holds the execution of a function until the surrounding you in the function has been evaluated and returned. You are in India. Uh, code below, we have a function that prints um, hello world, but in this case we have hello world. We have the word deferred. So unless the hello string has been returned, the word stays deferred. Such a weird way to write something. I don't know, it's just the way my brain wants it to be. Alright, so let's put a code block. Just say go. We say defer. Just say function. We say main, and we say we want you to defer. We could just say fmt.print. Print. We'd say service, and we'd say like, do you not, right, let's make it interactive. Do you, no, we just say service, and then we'd say defer. No, we'd not defer. We would then do like fmt dot print. You could just say like payment. Say payment. If we could just say payment would be so in this case, sorry, in this case only when there is a payment, and that's when you earn the service. So it's like that way. Based on my observation, which might be wrong, but I believe that the evaluation starts from the bottom to the top. Bottom to the top. Just like second differs. The first function's calls are pushed onto the stack. When a function returns, the first calls are executed in last in first order. So this is what I was trying to like understand. So more about the free movement. Okay, so function main content, and then we have default print I, then print done. Okay. Alright, so we default printing this, so that's why this gets executed like the last, and then we make sure that we print the counting first. Oh, that's very weird. Last in first order, default. Okay, I get it. Oh, pointers. I think that's all for tonight. I don't really want to do much tonight because or maybe later. But thank you guys for watching, and yep, that's it for today. We learned about um, we learned about the first statement. We learned about switch and switch evaluations. Switch is basically similar to every other switch statement in um, other languages, but the other different is that the switch statement in Go does not have a break statement. Yeah. Okay, so we learned about the switch statement, the difference between the switch statement and the switch statement in Go and the switch statement in other languages. There's no much big difference, but the only difference in Go is that it does not, you don't really need to add the break statement because that gets included automatically. So that's good. And also, um, it only evaluates the um, selected cases. So let's assume that you want to check if equals to 0, or if I equals to 1, if I equals to 2. So you could have other cases like, okay, if I equals to f, do this, but once it gets to this particular stage where I equals to 0, it would basically stop the evaluation. So, which is very good, meaning every other evaluation doesn't get in the way. It's more like, well, what should I use for that? Because it's more like, is it is it um is it bubble sort? I don't know. I can't really remember that because there's a sorting algorithm uh, that sorts a list. But once the list is sorted, it stops. It doesn't go through like once this list is sorted, it just basically stops its execution. It doesn't go on like check over again and again and again to see if um, it needs to like you know sort. So and then we also have something called a switch reality condition, and a switch reality condition is basically when you have like a default value for a switch, if that makes sense. But in this case, the default value is true, so you don't need to say like um, you don't need to like do well, how do I explain this? Like in the case where you want to like have a if and else statement, if this is true then do this, but the end cases is it's actually gonna do what it's gonna do, right? You could just have this kind of switch statement, right? And in this case, this switch statement checks if the time is now, and if the time is now, we want you to just print out the time, right? So it checks, okay, is the time now? Yes, the time is now. That's what it wants to do. Simple as that. Uh, what again did we learn about? Yeah, this I enjoyed. I think I like this a lot. The default statement. I think this is very good. This is a way to like defer a particular execution from happening because you need something to happen, right? Like you need to pay me before I render your service, right? So in this case, you have a service, maybe a plumbing service, teaching service, whatever it is. You can add a defer statement. So um, the defer statement would basically defer the uh, particular execution from function from happening only and if only if the payment has been returned, right? Which is very good. And one thing I did find out is the execution happens from bottom to the top. I mean, that was what I thought initially, but then I later realized that it is true, and that is because the defer statement execute in a LIFO order. Like, we have FIFO, and we have LIFO. We have the first in, first out, or we have the last in, first out. In this case, the default statement uses the last in first out, meaning that it would first execute from the last in, like the bottom, to the top, which is quite interesting. And we also learned about if with a short statement. This I also find very interesting in the sense that you can have a statement inside of an if statement, right? And the statement that you have inside of an if statement can be used within the if section and the else section, right? In this case, we have a statement if v. We have an if statement, but we have a statement also within the if statement, and the statement says v equals to mat.pow. So it checks for the power of a particular value, and if it is, we check if the result is less than um, lim or lim, whatever that was. If it is, then we return the value. If it's not, we return the value, right? So this is basically similar to this. We could have the statement before the if statement, and then use it within the if statement, which is what I think is being done in like every language that I've worked with, like Java or JavaScript. But this is new to me, and I think it's quite interesting. Uh, this way you cannot like mistakenly use a value that is not defined within the if statement. And yeah, it's a very good thing. And then we have the if statement also, which is just like every other statement, but the only difference with the go if statement is that it doesn't include a bracket in it. You have like an empty condition without a bracket. It's just like that. Unlike this with a bracket, this is how it would look like in Java, right? And in Go it's different. And then the other streams we did the while loop, we did the for loop, and some other stuff. So yeah, today we're just gonna stop in uh yeah, we're gonna stop with the default, and then tomorrow or later today we are going to continue with the pointers. Have a good day. Do you turn this off?